In this video, we want to confirm the given derivative. So we're given the derivative an expression and the answer is on the right. So this is basically an exercise in computing the derivative, a little practice in trying to get your answer in the correct form. And these come from problems that I did in earlier videos. So here's a situation. In one video I had the integral of x squared over x minus 1, and we got this answer. So this is just confirming that answer. It's just like checking your answer in an integration problem. Just practice. So take this derivative here, and we're supposed to get the integrand we started off with. Same thing throughout on this one here. The integral of this with respect to x. On the video we got the square root of x squared plus 2x minus 4. So if it's a true solution, then if I take the derivative of the answer, I should get the integrand. Now I'm leaving out the constant of integration on each of these because we know the derivative of a constant is 0. So let's start with the first one here. We got equals here, and then again turn by turn we'll take the derivative. Again, the constant I left it out. Derivative of a constant is 0, so this is going to be just basic integration. Bring the 2 out, cancels, and I get an x. Derivative of x, that's 1. And then when I have a ln of absolute x minus 1, whatever we have here, x minus 1 in the absolute values, goes at the denominator. And the derivative of this expression here, x minus 1, which is 1, goes up here. And I got a plus here. And then we just combine. So let's just say the denominator of this is x minus 1. So let's put this over 1. Multiply numerator and denominator by x minus 1. So that's going to give us x squared minus 1. And then we got this plus 1. Now we have the same denominator. Multiplying by x minus 1 here. And up here, this is what we get. I got plus 1 here. And then minus 1 and 1 gives me 0. So I get x squared over x minus 1. And that's the verification. That's the derivative. And of course, in the problem that I did, the integral of the expression was this right here. So when I take the derivative, I have to get back the integrand, which is the expression on the right. So this one checks out. And the next one again, the integral was right here. And this is what we got. We take the derivative. So again, we're doing this part right here. Equals. Take the derivative, and of course I have to get this over here. This is constant. So we can just take the derivative of the numerator and say this is derivative of secant is secant tangent of whatever the angle is. So it's secant of 3x, tangent of 3x. Then we got it over 3. And then because of the chain rule, we take the derivative of 3x and we get 3. So we get this value there. So this 3 and this 3 cancel, and we get the result. 3x, secant of 3x, tangent of 3x. So that one checks out. And then for the next one, again, this was the integral. In the video that we did, this was the integral. And we got the value for this integral to be this right here, square root of x squared plus 2x minus 4. So if I take the derivative of that, I should get the original answer. Again, the constant of integration, I left it out because it's going to be 0 when you take the derivative. Let's start with this part right there. So this is x squared plus 2x minus 4 here. So think of that to the 1/2 power instead of the radical. So I got a 1/2 here. So again, bring the 1/2 out in front. And then I have x squared plus 2x minus 4. And then I subtract 1 from the 1/2, and I get a negative 1/2. And then I have to use the chain rule. So I have to take the derivative of this expression right here, which is going to be 2x plus 2. And this will equal, and then just multiply the 1/2 times the 2x plus 2. 2's cancel out there, I get x plus 1. And then I'm left then with x squared plus 2x minus 4 to the negative 1/2. Because you have a negative exponent, we take it to the denominator, changes the sign of the exponent, so that'll give me this expression to the positive 1/2. But that's just the square root. So I have square root of x squared plus 2x minus 4. So it checks out. Don't need parentheses here, but 6 plus 1 over the square root of 2x minus 4, which is that result right there. Okay, we go to the next one now. This one involves, okay, we worked out this problem right here. Again, this was the integral in the video that we did. This is a dx here. We completed the square of the denominator here, and then we used the formula for that led to the integral of the arctangent, and it gave us this result right here. And we did use a u substitution. Here we're just taking the derivative just to check it. Okay, so this, we just clear this. So I just want to take the derivative here. So formula I'm using is simply the derivative of arctangent of u. That's the formula right here. I take the derivative of arctan of some expression u, where this u could be a function of x, and that's going to give me u prime. That means the derivative of u, okay? U prime. Same thing as du over dx. Just like this right here, same thing as d of this expression over dx. And then this is going to be 1 plus u squared. So in this case, this is going to be my u. Remember, this is constant right here. So that's not going to affect anything. How could we bring this out? So let's again start in this part right here. So I have the constant. So I'll just put this right here, 1 over the square root of 3. And in the numerator is the derivative of u. That's the formula that I had over here. It's the derivative of this expression right here. So this is a constant, this is a constant, so this is going to be 1 here, and this would be, the derivative of constant would be 0. So this is going to leave me with 1 over square root of 3. And this is 1, and the denominator was 1 plus u squared. The u squared is right here, or u rather is right here, x minus 2. Again, took the derivative of this right here. You can do it this way if you want x over the square root of 3. The square root of that, or the derivative of that, is 1 over the square root of 3, and then minus 2 over the square root of 3. But that's constant, so the derivative is 0. I'm left with this. And then in the denominator, again, it was 1 plus u squared. Again, this plays a role of the u. So it's x minus 2 over the square root of 3, quantity squared. And I'm just, instead of writing the whole thing again, I just put this in the bottom here. So it's 1 plus. Let's square this. That'll be x squared. X minus 2 squared, squaring a binomial. So it's x squared minus 4x plus 4. And then square the radical 3, that gives me 3. And now this right here, I multiply by the square root of 3 here and here. Cancels it over here, and it gives me the 1/3 here. So this actually winds up as a 1/3 out in front. And then for this one here, I multiply through by 3. So that gives me a 3 here, plus, and then here it cancels the 3 on this one. So this gives me x squared minus 4x plus 4. And because I have a 1/3 over here, when I multiply the numerator by 3, the 1/3 times the 3 gives me a 1. So I get a 1 right there. So then we just simplify this. This is going to be 1 here. And we have x squared minus 4x. And then 4 and 3. 4 and 3 is 7. So again, this is just an exercise on how you can check your answer. If you integrate something, take the derivative of the answer. It should give you the integrand. That's all this is. It's a little practice with algebra, simplification, and so forth. But you can see we get the result we wanted, which is confirming the derivative. We got this. Thanks for watching. We'll see you next time.